The locations of the wikis is a great place to actually get more information of what's happening, and all the information that I'm presenting there pretty much are outlined there. Basically, a couple of years ago, when you wanted to have Xen, you had the option of, well, let me back up first. If you want to boot up Linux, you can boot it on a couple machines. You can boot it as a guest, you can boot it on bare metal, and you can boot it on Xen, you can boot it on KVM or whatnot. If you boot it on a virtualized environment like a hypervisor, it's called paravirtualization. The thing about it, though, is it requires certain modifications inside of the kernel. So in the past, there were two variants of kernels. If you installed CentOS 5 or RHEL 5, you had two variants of kernel. You had the one that was booted bare metal and the one that would boot under Xen, the so-called kernel Xen. Well, the thing about it nowadays is, thanks to Jeremy, who's been doing a lot of this work, there is a set of operations in the Linux kernel that allow it to basically detect if it's running and what kind of platform it's running under, either being HVM, bare metal, under Xen, if it actually has SNMP or if it's UP, all of those things. It can figure out as itself. The way it does it is, well, I'm not going to go into details at it. The wiki has a good explanation, and if you have more questions about it, we can answer those later on. The end result is that basically you only have one kernel that can boot under all those platforms. So none of that, you know, oh, I have to run now Xen, I need to have this extra kernel, whatnot. That's not needed anymore. It also, for distros who are kind of a consumer of this, it makes it easier for them because in the past they were saying, okay, if you have a hardware box and you want to certify it, you have to test your distro, and guess what? You have two kernels you have to test. So it expands their test matrix and didn't like it. Well, with this thing, you only have one kernel, so that lowers their costs, and they're much happier about it. The last one is more of how the code was structured, that was a lot of them were defined by if-defs, which meant that the code was a little bit unmaintainable, and a lot of the people upstream did not like it. So the difference between the old, which I call the Xen Linux, and the new one, PVOps, is a kind of a summary of it. What was, as I earlier mentioned on the kernel, you could only run under Xen. Now, with PVOps, you can run it on all different ones. Now, there's also a lot of benefits to the old one. There's also a bunch of disadvantages with it. Let me go first, kind of hodgepodge between them too. One of the nice benefits is that it has a lot of drivers in it. Some of them we don't actually use that much, but they are still there. For example, you have a PV-SCSI one or PV-USB. It's also super stable. If you run a RHEL 5 or Linux 2618, it's quite stable. It works pretty well, except that it doesn't have all the drivers for the new hardware. So if you try to load it on the Halen box or some of the AMD newer machines, boom, you can't see the hard drive because it doesn't have the drivers for the adapter. The other side, as I mentioned earlier, those patches aren't really upstreamable. The people in the Linux kernel community do not want to look at it. Now, why am I talking about upstreamability? Why is that important? The fact is that a lot of distros want to save money. And one way to save money is to lower down on maintainership. And one way to lower down maintainership is instead of having 2 or 3 guys working on maintaining the code, you have great Linux community that will do it for you and help you along. So that's part of why we're trying to get the Xen pieces upstream so that the Linux community can help us along. The performance one, until recently, there was this issue where, well, we couldn't do performance analysis that well. If you take a 2618 kernel and a 2632 on a bare metal, just bare metal, you will find a regression with 2632. There have been a lot of patches added recently that I think some of them fixes it, but the point was they're like apples and oranges. You could not do a good comparison. Now with Celeste coming out, Novell, and as well as some of the other patches, there is a 2632 variant of the Xen Linux. Now we have a PVOps, and we can kind of do the performance analysis and see where we actually are missing. With the PVOps, the only other thing I can mention is sharing code base with common code function. That is a great advantage. The PVOps, as it being one kernel, it boots on a lot of hardware, so it gets a lot of testing. And lastly, that's where new development is happening. So bug fixes, ways to fix stuff, pretty much all of them are being done there, with the exception of different distros, which is the next slide. And they, of course, maintain their code. So for example, if you buy Oracle product, we give you a long-term maintainership of we're going to keep it up and help you. But if you're trying to use something new bleeding edge, and you want to go with the new things, then you have to end up using PVOps for the Zen parts. There are two distros that are, well, one of them, Fedora Core, is kind of unofficially making already RPMs, and Debian Squeeze also announced that they will have a PVOps kernel. All right, so I'm going to go a little bit of what we are trying to achieve and how we're trying to get all the code upstream. What we have to understand is there's pretty much three code camps, for the lack of better words. There is the ones that are dealing with unprivileged PV. So those already exist upstream. If you run Fedora Core, as you guessed, it boots automatic. You don't have to do anything. As I said, it's one kernel, it does everything. It doesn't have all of the front-end drivers, but it has a lot of them. The other ones, it's the DOM0, it's more the privileged domain, the one that you need for setting up our queues, setting up the devices, setting up frame buffer, whatnot. And then lastly, there's code that's shared between those, and it's also shared between normal platform, like x86 platform. So we have those, keep in mind, those three code camps. And we've split the kind of the work in a bit where Jeremy keeps most of them, I keep some of them, and to kind of get it upstream, we try to separate those pieces of code in functional pieces. So, for example, a great example is APIC stuff. There are a bunch of stuff that we need for programming the IOPIC controller. They're all in one branch. So if we want to push them upstream, it's all nice functional components. Some of them are built on top of each other. For example, if you want to have PCI front, you need that. Now, for those that don't know what PCI front is or not so much familiar, Zen offers two methods of passing in a PCI device into guest. If you have fully virtualized, meaning HVM, and you have Intel or AMD new hardware, you can pass it on, and it's either SRIV or normal PCI, and the IOMMU works as a mechanism to allow the code to run properly, the operations. If you have much older hardware, you can use something called PCI front-end and PCI back-end, where it does not require that, but it requires the guest to be PV. So that's another device module that has been in Linux 2.6.18, and now it's in PVOps, and there's some dependency on it to make it interesting. So, gotten through the code branch. As I mentioned, this path of getting this code upstream is a little bit difficult because it's hard. There are patches we send upstream, and they say, well, this looks great, but you could do it this way, or you could do it that way. So we constantly have to refactor and figure out a better way to make it work, and also not just for Zen, but for other platforms, since some of this code is shared. As well, to make sure that we're not screwing anything up, that the pieces of things we're adding in aren't doing bad stuff, we actually have to make it stable so that also distros can pick it up. And lastly, that there is no bit rot where some code function only worked in the earlier versions but don't work in newer, we have to rebase it. So an example here, which I'm going to really go quickly through, is I mentioned the software ITLV. For those that don't know about it, it's an old mechanism for making DMA operations work. And the Zen requires some extra stuff, so there's a bunch of pieces to put that upstream, and we've been working through it. So this is kind of a small status list of what's been happening so far and what is next on the radar for us to do. There's probably more that I have not gone through. We can talk more, and if there's interest to it, I think we can put up a wiki where we explain which one, though I think in some way we already have done that. I'm not entirely sure. The stabilization part is kind of interesting. So thanks to the community, we have been able to not only push these different branches, which means there's kind of two branches, or there's more than two, but The ones that are most important for us in the community are these stable branches. But what it basically is it's all the Zen patches on top of Linux branches that are different kernel versions. So we have a 2.6.31, 2.6.32, 2.6.33, and then each of those has Zen patches on top of it. The idea is to keep it and track it as the Linux community is going forward so we can get all those upstream patches. It also makes it easier for the distros to pick it up if they like to do so. Now, a lot of the community has been testing, very much welcome. There's been wiki written about it, very much welcome. Any time you test this and you provide a test result that says, oh, this works, please send us away. If you find that there's a problem, tell us as well. We might not get to it immediately, but we do keep kind of a track of what's happening so we can try to fix it and get it done. We want to get it done. The other one that I mentioned is the development branch, and that's pretty much where all of the patches that we have, we stick onto that one, and when those are stabilized, we then put it onto stable ones. All right, I mentioned about the rebasing a bit earlier. I think the one kind of interesting is that Jeremy is now taking the 2.6.34 and rebasing everything on it. It's still not there. We'll have it eventually. All right, next slide. Outstanding issues. So all of this, we want to have a stable kernel. We want to have one that will work so that when we start submitting patches upstream, it's not like it doesn't work. It has been tested, not only by us, but by the community as well. Currently, there are some outstanding issues with the X server. So if you try to run X, or it sometimes works, sometimes it doesn't. There's been work on it. One guy from India spent 3 weeks doing, and he came up with one-line patch. So some of these problems are just, they take a long time to get through it. There's also some issues with the DOM-U and DOM-0 not having the packets across, and there's another guy working on that as well. So there are some outstanding issues. The one other thing that we've kind of run into is the compilation of kernels and booting it. While we test it, we don't test all variants of it. So if you test a different variant of .config and it works for you, please send us. If it doesn't work, by all means, do send it to us. And I'd like to thank everybody. Without you guys, well, there would be no point of working on this one. But you guys have been doing this great job testing it, and it's really nice to see so many people and helping along on RSC and as well on mailing lists. Thank you. Please be patient with us. We're trying to get those things working, bugs and so forth. It takes time. So thanks, guys. I'm not going to go in detail on this one. These slides are going to be available online. So if you're interested in exactly what they are or what's happening, which branch has what you want to copy, these last 3 slides tell you what Jeremy's has, what mine have, and then also Stefano's. And I completely forgot to talk about Stefano's, which I think we still have got some couple more minutes. One of the things that we've also been working in development is it's kind of a hybrid mode where the guest runs as HVM, but then as it runs, it swaps over to be PV. So all the drivers become para-virtualized. It also speeds up on the IRQ process. Now this has a great benefit on the newer machines which have either the Intel EPT or the AMD, well, I forgot the name for their hardware piece that does it, but basically to make the page table walk much faster. All right, Jeremy, come on, help me out with questions if there are any questions. I can't believe I went through this one and no questions.
The thing I found when I did the talk in Shanghai is that if you beat them to death with like a, say, hour-long presentation, then there's no questions, or at least there's no time for it. So.
Well,
Yeah.
I mean...
There has to be some questions
Oh,
about
there's
this one.
a gentleman in the back.
So, okay. Can you talk more about the net channel 2 and the status of that?
Well, so the 2631 tree has net channel 2 in it, but I didn't really get any feedback at all as to whether or not it works and whether anyone was really using it or anything. So I decided not to put it into 2632 just to see if anyone would complain, and then if someone asked for it, then I'd immediately have a tester. So I didn't really want to put the code in without having someone immediately, with a use case. So if you want net channel 2, I'll happily merge it, and then it's up to you to test it.